to all. My name is P. Antopal Merindo from Mechanical Department, Moorafin College of Engineering. My topic is comparator. Comparator is nothing but a device which is used for comparing known value to unknown value for the mass production. Comparator is an instrument or a device used to compare a physical quantity being measured with known or calibrated reference standard. It is an essential tool for ensuring accurate and precision measurement. Types of comparator. There is a different types of 5 types are there: mechanical comparator, electric, pneumatic. In mechanical comparator, the major divisions are that is a dial indicator comparator, sigma, pneumatic, and lever comparators. Then electrical converters are divided into 4 types, that is AC converter, AC DC converter, digital converter, radio converter. Then optical converters have 3 types. First one is profile projector, tool maker microscope, optical converter. And fourth one is that is pneumatical converter, that is divided into 2 types. First one is air gauge converter, next one is pneumatic LVDT converters. Next, fifth type is electronic converter. It is also divided into some types. That is a digital multimeter or oscilloscope, LCR meter, time interval counter, etc. Then we have to explain about the mechanical converters. So these shows in the mechanical converters. So the major components are: first one is the base, then the post. The post we have to fix that's a dial gauge. That is a dial gauge is a pointer. There is one pointer. The pointer shows the value of the in the digital. That is a 0 point we have to fix it. By the initially we have to fix the, we want to measure which compound we want to measure. That compound is we have to fix the table. Then we have to remove the component. Then we have to fix the slip gauge. Then we have to set the 0 value. Then we have to remove the slip gauge. Then we have to measure which component we want to measure. That component we have to insert. Suppose the component accepted means that is a pointer is 0. The component is maximum size means the dial gauge move forward or reverse. So depends upon the component we can source, that is a component accept or reject. Okay, so that is the fundamental components are, that is a base, then dial indicator, probe. The base means withstand all the components, and all the components are placed in the base. So it is a it is fixed on the floor. Okay. Next one is that is a dial indicator. It's dial the needle. So it is based on the mechanism of mechanical. So we have to say that is a mechanical converters. So the dial indicator mechanical or electric device that the measure instrument displacement or dimension for weight. It consists of a needle or pointer. Probe. Next one is the major component is probe. Probe is a part of the dial indicator that makes contact with the workpiece or reference surface. So the probe will touch the workpiece, or then only the pointer will move up, forward or reverse. It depends upon the probe. Only we can assume the component is accept or reject. Next one, measuring process. It is used to dial indicator converter. You would first set the reference point using the known standard or reference surface. Then you would to bring the probe in the contact with the workpiece. Then after we have to remove the workpiece and we have to insert the dial gauge. So we have to set the 0 value. Then we have to remove the dial gauge. Then we have to which component we want to measure. We have to insert the object or component. Next one is comparison. So we have to remove the slip gauges, then we have to insert the component. At the time the probe will touch on the workpiece. Suppose it will touch mean the needle source 0 point means we can assume that the component is acceptable. Otherwise the component is reject. That is the mechanism. So here we can use the gear mechanism. So we have to say that is a mechanical comparator because there is a rack and pinion mechanism. So there is one stylus is there. In the stylus, the pointer is fixed. The pointer is fixed on the rack and pinion mechanism. So if the probe will move for upward direction, the needle move also depends upon the movement of the probe. the pointer will move up and down motion. So by the we can using the gear mechanism. So we have to say that is an mechanical comparator. Mechanical movement. So the dial indicator comparator consists of a plunger or probe that moves in a response to the contact with the workpiece. The movement of the plunger is typically achieved through the rack and pinion mechanism. So we have to say there is a mechanical comparator. Okay, next one is that's a plunger. Plunger is a part of the dial indicator that makes a contact with the workpiece. Okay, the probe will contact the workpiece. At the time the probe will make zero, or suppose the workpiece is the size will large, mean the needle move forward or reverse direction. So that is the working work of the plunger. Next on spring mechanism. The spring mechanism will control, it will forward and it will control the movement. Next one indicator display. So the indicator display the compound is acceptable, or that means the 0 point means it as well. So it will maybe forward or reverse direction. So it will display on the indicator. Then calibration. So we can the calibration means with the probe the comparators is we can calibrated 0.001 inch or 0.01 mm. Next one, reading. To take the measurement, the operator will bring contact with the workpiece and read the displacement indicator on the dial face.